Welcome back to the Solutions Manual. In this video, we will solve the problem 3-26 from RC Hibbeler Engineering Statics 12th edition. According to this problem, we have to determine the tensions developed in wires CD, CB and BA and the angle theta required for equilibrium of 30 lb cylinder E and the 60 lb cylinder F. Now to solve this problem, let us draw the free body diagrams of point C and B. FBD of point C. So point C is a particle. So we have a one inclined force at an angle of 30 degrees from the horizontal. We have a vertical force acting downwards, that's the weight of cylinder E. We have another declined force at an angle of theta. Let's label them. This right here is 30. It is at theta degrees, and let's call this TCD. This right here is TCB, and that's the weight. It's 30 lbs. Now we can see that I can resolve these two tensile forces TCD and TCB into their components. So I have one horizontal component and one vertical component. Similarly, for this force I have one horizontal component and one vertical component. So let's label them as well. This right here is TCD sine 30, and that component is TCD cos 30. This right here is TCB cos theta, and this vertical component is TCB sin theta. Now we can write the equations of the equilibrium. So our first equation is summation of forces in x direction equals to 0. I am considering right hand side as positive. So we have TCB cos theta minus TCD cos 30 equals to 0. Let's call this equation 1. Similarly, I have the another equation, that is summation of the forces in y equals to 0. I am considering up direction as positive. So we have TCD sin 30 minus TCB sin theta minus this 30 lbs equals to 0. Let's call this equation 2. Now we have to do the same for the point B. So if I draw a free body diagram of point B, then it would look something like this. I have one force inclined at an angle of 45 degrees. I have a vertical force, and I have another force that is inclined at some angle. This right here is 45 degrees. Let's call this TBA. This right here is the vertical acting force is 60 lbs, the weight of the cylinder F. And this right here is TBC. Now for this angle, if I look into the figure again, and if I draw a horizontal right here, then this angle right here is also theta, because it is alternate to that angle theta. That's why we are also going to consider this angle right here as theta. So now we can resolve them into their components. So we have one horizontal component and one vertical component. Here I also have a horizontal and a vertical force component. Let's label them as well. This right here is TBA sine 45 degrees, and that component is TBA cos 45 degrees. This right here is TBC sine theta, and that horizontal component is TBC cos theta. Now I can apply the equations of the equilibrium. So our first equation is summation of the forces in x direction equals to 0. I am considering right hand side as positive. So we have TBA cos 45 degrees. One more thing is that the TBC means exactly the same as TCB. So both means the same. They are the same forces. So in place of TBC, because we have used TCB here, so I'm going to just write TBC as TCB. Let me write it in a box, and let's say it's a hint. Now we have minus TCB cos theta equals to 0. Let's call this equation 3. We have another equation, that is summation of the forces in y direction equals to 0. I'm considering up direction as positive. So we have TBA sine 45 plus TCB sine theta minus 60 equals to 0. Let's call this equation 4. So now we have four equations. We have four equations and four unknowns. But how to solve them? Now I can see from these four equations that in these equations I have TCB, a common force. So if I consider equation 1, and if I make TCB a subject, so equation 1 becomes TCD is equals to TCB cos theta over cos 30. And I'm going to put TCD in equation 2, this equation right here. So equation 2 becomes TCB cos theta over cos 30 multiplied by the sin 30 minus TCB sin theta minus 30 equals to 0. And when we simplify it, what it becomes? It becomes TCB cos theta and sin 30 and cos 30 becomes tan 30 minus TCB sin theta minus 30 equals to 0. If I take out TCB as a common, it becomes cos theta tan 30 minus sin theta minus 30 equals to 0. And if I make the TCB as a subject, then it would become 30 over cos theta tan 30 minus sin theta. Now let's call this equation A, and this is very important equation. Now I am going to do the similar with the equations 3 and 4. So from equations 3 and 4, consider equation 3, and if I make the TBA the subject, the equation 3 becomes TBA is equals to TCB cos theta upon cos 45 degrees. Now I am going to put TBA in equation 4, in this equation right here. So equation 4 becomes TCB cos theta over cos 45 multiplied by sin 45 plus TCB sin theta minus 60 equals to 0. Now upon further simplification, sin 45 and this cos 45 becomes tan 45 plus TCB sin theta minus 60 equals to 0. And we know that tan 45 is equals to 1. So upon further simplification and after taking out the TCB as a common, our equation simplifies to 60 over cos theta, just the cos theta, because this tan 45 becomes 1 plus sin theta. Now let's call this equation B, and again this is very important equation. So now we have two equations and two unknowns. So if I compare, because the TCB is same in both the left hand side of the equations A and the equation B, so I can compare equation A and B. So we have 30 over cos theta tan 30 minus sin theta equals to 60 over cos theta plus sin theta. Upon further simplifications, we have 2 right here, and then we can do the cross multiplication. So we have cos theta plus sin theta is equals to 2 times of this whole bracket. Now I can do one more thing. I can divide both sides by cos theta. It would become cos theta over cos theta plus sin theta over cos theta is equals to 2, and in the bracket we have cos theta into tan 30 over cos theta minus sin theta over cos theta. So upon the further simplification, this one cancels out, only the 1 remains. This cos theta and that cos theta also cancels out. So 1 plus tan theta is equals to 2 into tan 30 minus tan theta. Now we can easily solve it to find the theta. We have 1 plus tan theta equals to 2 tan 30 minus 2 tan theta. Upon the further simplifications, we have, if I shift it to the other side, we have 3 tan theta is equals to 2 tan 30 minus 1, and then theta is equals to tan inverse of 2 tan 30 degrees minus 1 upon 3. So when you solve it, your answer would be 2.952 degrees. So now we have found the value of theta. By using this value of theta, now we can find the TCB. So put this value of theta in any of the equations A or the equation B. So let's say put theta equals to 2.952 degrees in equation B. Let's say this equation right here, because that's easier to solve. So we have TCB is equals to 60 over cos theta, and now we know the value of theta, that's 2.952 degrees, plus the sine theta, and again the theta is 2.952 degrees. Upon further simplification, your answer for TCB would be 57.133 lbs. That's our first answer. Now we have to find the other forces. So if I move back to the upper equations, the equations 1, 2, and 3, and 4, let's say, so now for the forces TC, D, and TBA, put theta equals to 2.952 degrees and TCB equals to 57.133 lbs in equations 2 and 3. Yes, you can also use the equation 1 and 4, but we are going to solve it by using the equations 2 and 3. So this right here is the equation 2. So equation 2 becomes TCD, let me zoom out a little bit. TCD sine 30 minus, now in place of TCB, I have the value, that's 57.133 multiplied by sine 2.952 degrees minus 30 equals to 0. So when you simplify it, it would become TCD is equals to 65.884 lbs. Now we have to do the similar process for the TBA. Let's call this answer 2. Now consider equation 3, this equation right here, this one. Take a look at it. So we have TBA cos 45 degrees minus, now we know that value of the TCB, the value is 57.133 lbs. So 57.133 lbs and then multiplied by cos theta, and theta is 2.952, we just have found, equals to 0. So from here TBA becomes 80.691 lbs. Now this is our answer 3. This is our third answer. So we have found the forces TBA, TCD, and TCP. So this is it for this problem. I hope you will find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts about this problem, then feel free to ask in the comment box and I will answer it as soon as possible. Thank you.